Welcome to the GCSE Statistics Higher Session 7. This session is focused on time series and moving averages and consists of 4 subsections: calculating moving averages, plotting moving averages on a graph, drawing and using trend lines, and seasonal variation. So calculating moving averages, you could be asked to calculate 3-point, 4-point or 5-point moving averages. Let's take a look at an example on how to do this. The table shows information about the quarterly gas bill in pounds for Samira's house over a period of 2 years. We're going to work out a 4-point moving average. So this is very similar to calculating an average as normal. However, we're going to calculate several averages as we move across. So if we take a look at the first one, we're going to select the first 4 quarters. 1, 2, 3, 4. So to find the first moving average, we will add up these 4 values and divide by 4. So 200 plus 162 plus 80 plus 130 all divided by 4 gives us a moving average of 143. To calculate the second moving average, we're going to shuffle along one. So instead of starting here, we'll go 1, 2, 3, and then here to find our 4th value. So our second moving average, add up these 4 values and divide by 4, which gives us a value of 147. For our third moving average, we're going across here, starting 1, 2, 3, 4. Add them up, divide through by 4, and our third moving average is 148. Similarly, going along again, take the yellow, shuffle along 1, going here, 2, 3, and 4. Add up all 4 of those values, divide by 4, and our 4th moving average is 152. And then the last moving average we can work out with the data we have here. Moving along, we're going 1, 2, 3, 4. So the 5th moving average for this data set, adding up these 4 values, dividing through by 4, is 155. You'll not normally have to calculate all of the moving averages, but normally a few. Normally these are the last few, so you might want to work backwards to find the last one with the purple here, and then the yellow, the 4 before that. So once we have these moving averages, we then need to be able to plot these moving averages on a graph. Really important that we plot the middle of the range of the values for which they are an average of. So if we look back here, our first moving average, the green one, is from 1 unto 4. So the middle is going to be here at 2.5. So if we were to plot our first moving average of 143, we're going to be plotting it here at 2.5 and then going up to 143 here. Our second moving average that we calculated was 147. So we go across 1 into here, 3.5, and we're going up to 147. Which is going to be here. Then 148, just there. Then up to 152. And lastly, 155, which is about there. Now you may have to comment on the trend without an actual trend line. So we can see here that the trend is going up slightly. Obviously the scale here, the numbers are quite close together, but the trend is increasing slightly. So once we've got that point on, we may have to draw an actual trend line, and this is a line of best fit for the moving averages. So we go back here to our moving averages. If you take your ruler, we can draw a line of best fit through these points, and we can see that the line is going up slightly, and that gives us our slight upward trend. You're sometimes asked to use the line for predictions. And if the prediction is close to the values you know, for example, the next quarter, the prediction will be reliable. However, if the prediction is sometime in the future, such as 3 years ahead, making a prediction based on this data would be unreliable. So if we take a look here, and we're looking at the gas bills. If we were predicting year 3, we've got here year 2, and if we go to year 3 and quarter 1, making a prediction here would be reasonably reliable. But if we were looking at making a prediction for year 5, that's too far in the future. So a prediction for this here would be unreliable because we're extrapolating too far. We're going too far away from the range of data that we have. Let's take a look at an example here. Here we have the time series. These are all the points at each one of the quarters. The line going through is the trend line, and we're asked to describe the trend of the sale of soft drinks over this period in the shop. The trend is increasing. So in this case, we'd have to say, is it increasing, decreasing, staying the same? We can see our line is going up, the trend is increasing. Now, seasonal variation. We could read this from the graph. Seasonal variation, if we look back at our quarters here, we can see here that in quarter 1 it's quite low. This is at the beginning of the year, January, February, March for the first quarter. This here is quite low. Whereas the third quarter up here is high. And this is known as seasonal variation. The different seasons, it's varying. So important for this for interpretation is to know what the different quarters mean. If this is based in years, quarter number 1 will be January, February, and March. Quarter 2, April, May, June. 3, July, August, September. And quarter 4, October, November, and December. So when we're interpreting, we need to think about maybe the weather's different at this time, therefore the number of drinks go up. Maybe it's school holidays. Things that are going to affect the sales of things and therefore the trends of things. So we can see here that we have variation. Now, if we look here at the notes, seasonal variation is equal to the actual value, subtract the predicted. And we can do this from the actual graph. So if we take a look here and say, for example, we're looking at the point here at quarter 4 in 2005. We're looking at our value here and reading across 200. And here, the trend going across is 225. So here we have our actual being 200 and our predicted being 225. So here is the difference. That part there is the seasonal variation. And to work that out, we take the actual, which was 200, and subtract the predicted, which in this case was 225. So we're going to get a negative seasonal variation of -22. It means that actually we were down 25 from what was predicted using the trend line. So in example number 4, we can see seasonal variation. This time series graph shows information about the quarterly sales of soft drinks in a shop. A trend line has been drawn on the graph. Now we can see on our graph at this point here, in each of the years, we have the highest number of sales in this quarter. Quarter 3, the sales are higher. The actual sales are higher than the predicted from the trend line. Similarly, when we look here at Q1, we're looking at a lower number of sales compared to other times in the year. Now, seasonal variation, we actually can work out, and we use the information here on the graph to find the actual, subtract the predicted. And the predicted is from the trend line. So let's take a look. We're interested in the fourth quarter of 2005. So we're looking at 2005, the fourth quarter. We're looking at this value here, which is the actual, and this value here, which is the predicted. So let's take a look here on our graph using a ruler, or put your finger across. Actual value, well, actually the number of sales was 200. The predicted from the trend line was higher. It was up here at 225. So our seasonal variation for this particular quarter, the fourth quarter of 2005, is negative 25. Why is it negative? Because the actual values are lower than the trend line. So it's now question time. Press pause on the video and complete the question booklet. Once you've completed as many questions as possible, come back to the video, press play, and we will go through the questions together. Question number 1. The time series graph shows the values to the nearest 1,000 million for the total exports from the United Kingdom between 1997 and 2003. We're asked to draw a trend line on the time series graph. Now, a trend line is a line of best fit of the moving average points. So here you need to take your ruler. You need to make sure that your line goes through as many of the points or as close as possible to the points shown here on your graph. Using a clear ruler here will ensure that you get your position of the graph correct. We're then asked, what does the trend line show about the total United Kingdom exports between 1997 and 2004? What's happening? They are going up. They are increasing. We're then asked to use our trend line to predict the total United Kingdom exports in 2004. 2004 is here. Taking your ruler, we're seeing what our trend line shows us about 2004. So here, we're going down to 2004, and then we can read our value across here that will give us an idea about the exports. So this trend line suggests that the exports using the scale correctly, 286. Using the line of best fit here, the trend line to predict, we have 286. Now you need to be aware that in the exam, the examiner will accept any answer between 280 and 290. So you need to check that your answer is within this range. You'll then ask, why might this prediction for the total United Kingdom exports in 2004 be unreliable? Are we predicting within the range of data? No. Our data runs from 1997 to 2004. So why is this unreliable? Because we are outside the range. If we are outside the range, we have not within, it is unreliable. we have actually extrapolated, and this is unreliable. We have extrapolated, mathematically known as extrapolation, going without estimating outside the range. We're then told that in 2005, a whole year later, the United Kingdom exports was 273. So looking here, 273 is approximately here. Using your line, you can see where that corresponds on the trend line. So the line here. And we're asked, does this figure follow? So we're looking here again, 2005 here. Does this follow the overall trend for the trend line on the time series graph? So in 2005, having exports of 273, does that follow the trend line? No, you can see here that if the trend line continues, you would expect the values to be up here. The value of 273 is much lower. So, does this figure follow the overall trend? No. Why? Because it is below the trend line. And in this case, significantly below the trend line. It's very far away from the trend line here. Question number 2. The table shows the number of cooling fans sold by Breeze Engineering each quarter for the years 2002 to 2004. We're told that the data has been plotted as time series. A 4-point moving average are also shown. So here we have the time series, the line going up and down, and then here the points is the moving average, the 4-point moving average which has been plotted. First off, we're asked to draw a trend line for this data. Now the trend line is the line of best fit through the moving averages. So we need to get a line that goes approximately through these points. So somewhere roughly like that on your graph. We're then asked to write down what the trend line shows about the number of cooling fans sold between 2002 and 2004. So what's happening to our line here? The trend is increasing. So what's happened to the number of cooling cans being sold? They have increased. So the answer here to our part B is increased over this time period, 2002 to 2004. We're then told that the graph shows the season of the years affected by the number of fans sold, and we're asked to write down a reason why. So here, the season of the year affects the number of fans sold. Looking back here at our graph, we can see that they're going up, and at this point here, here, and here, during the third quarter, which we can see here, is the largest. 120 is the largest number for that year. 125, also the largest for this year. And then 2004, quarter 3, is also our largest. So we can see here the reason why is because in quarter 3, we're looking at the months July, August, and September. And this is going to be the warmest point of the year, therefore more fans are going to be sold. So our answer here give a reason why it is warmer. In quarter 3, so more fans are sold. Again, we can see here that in the winter, down here, we're looking at the smallest numbers between quarter 1 and quarter 4 during the winter. So you might want to compare this. It's warmer in quarter 3, more are sold. In quarter 1 and 4, less are sold because this is during the winter time. We're then told that the value of the average seasonal effect for the first quarter is negative 13.8 and asked to calculate the predicted sales for the first quarter of 2005. So, predicting from the trend line, coming back here, in 2005, we're looking at the first quarter of 2005, which is here. So our trend line is going to need to be extended. So having our trend line here, I'm going to extend it across. Again, keeping it in the same, but extending it across here. So taking our ruler again and going up from the first quarter of 2005 and up and across. We're looking at a value here predicted from here to be 126. So 126 is predicted from the trend line. So we have here from the trend line 126. So we take 126 and we subtract 13.8. This is the seasonal effect for the first quarter. So we're replicating this for the first quarter of 2005, which gives us predicted sales of 112.2. If we look back here, we're not expecting the sales to be on the trend line. We're expecting them to be lower by 13.8. We can see here that in one, they're lower, in one here, lower than the trend line, and again here lower. So by using this, we're trying to predict how much lower they are. So we subtract that from the predicted value of 126. We're then asked to write down 2 assumptions you made when predicting the sales for the first quarter of 2005. So 2 assumptions. Now we mentioned this already. We're assuming that both the trend line, and the seasonal variation continues. We're predicting that this is the same and that the line is continuing. So our 2 assumptions are that both the trend and seasonal variations continue. We're then asked how reasonable these assumptions are. These assumptions are very reasonable. Okay, we're not looking at something that's too far beyond. We're looking at here, we're looking at the number of fans. The weather's going to be very similar in terms of the variation, and the trend is likely to increase. We're not looking too far beyond the current data that we have. So when we're asked how reasonable these assumptions, we can say they're reasonable. If you like, even very or quite reasonable. Question number 3. The table shows the earning each quarter from tourism to the UK from the first quarter of the year 1999 to the second quarter of the year 2002. This data is shown below on the time series graph. So we can see here the earnings from tourism going up and down. And then we can see here the triangles is where the average, the moving average has been plotted. Our first question, we asked in which quarter in each year was the greatest amount of money earned? We can see that from our graph, here, here, here. These are all quarter 3. And we can also see it here that these are the highest values. So the answer to our first question here when we're asking which quarter, quarter 3. We're then asked to give one reason why the earnings from tourism were higher in this quarter of each year. Well, quarter 3 we know is the third quarter of the year, and this is where the months of July, August and September. So tourism, the earnings from tourism is higher. One reason, the weather, the summer holidays, children are not at school and going on holiday, prices are sometimes higher, lots of people visit the UK during these months. Any of those reasons will be plausible and will get you 1 mark. We're then told that the first 4 quarterly moving averages in pounds million to the 2 significant figures are below. These are listed here. We're then asked to calculate the last 2 moving averages. So looking back at our table, the last two moving averages, we're looking here at these numbers and these numbers for the last one. So we will add these numbers up, here, 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 and here, divide by 4. So the last moving average is 2,700. The moving average before that in another colour are these numbers and here. Adding those up and dividing by 4 also gives us a moving average of 2,700. We're then asked to plot these on the time series graph. So we can see here that we're going across from here in the middle between quarter 2 and quarter 3. So here, again, we're going to go up to 2,700, which is approximately there. And then again here, 2,700. So use the same scale that they've used here, using the triangles to plot the 2 points. We're then asked what can be inferred or implied to come from the moving averages about the way the earnings from tourism have changed for the years 1999 to 2002. So what's happened over these times? Now there's 2 marks available. Our first mark is going to be looking here. We can see our moving averages going across and they're quite stable. There's a little increase here, but actually between 1999 and to 2000, to the end of 2000, which is this point here, all of these moving averages, they're roughly the same. So at this point, between 1999 and the end of 2000, the earnings are similar, okay? So they remain the same. However, from this point onwards, quarter 4 here, we can then see, put in a different colour, that they've dropped. There has been a decrease. So from 2000 onwards, there has been a decrease in the trend. And we can see that from these 2 points as well. These 2 years, roughly the same. This one's a little bit higher, and then there's a big drop. Same here. These for quarter 1 here and here, roughly the same. Then there's a big drop again. So here, this is what I get our first mark for commenting on where it's the same, roughly the same, and the second mark for noticing the decrease in the trend. Question number 4. The table shows the number of people in hundreds going to a small cinema for 12 consecutive quarters. It also shows some of the 4-point moving averages. We have some here that have been calculated for us. First off, we're asked to complete the table to show the 2 missing 4-point moving averages. So our moving average from here, we've got a 4-point moving average. We're going 75, 55, 105, and 141. We're adding these numbers up and we're dividing by 4. Adding these numbers up and dividing by 4 gives us a value of 94. Looking at our next moving average, we're starting at 55, 104, 105, 141, and 87. Add them up, divide by 4, gives us a value of 97 for the 4-point moving average. We're then asked to plot this information onto the time series graph below. We can see here the moving averages have already been plotted and we must plot the remaining 2. So first 94, which will be here between our 1 and our 2. The last one was between 4 and 1. So now we're between 1 and 2 and we're on 94. So that's just here on the line. Then our next value is 97. So here between 2 and 3, going up to 97. This is 96, this is 98. So halfway is the point that needs to be plotted there. You're then asked to draw in a trend line for the moving averages. So taking your ruler and constructing a trend line. we can see here that our line is approximately going in this direction. It is staying reasonably flat with a small increase. We're then told that the seasonal variations for quarter one in hundreds are -42, -44 and -40, and asked to calculate the average seasonal variation for quarter one. Let's just take a look. Quarter one is here, really far below the trend line. If I extend it, you can see, if I extend backwards the trend line, this is much below. Quarter one here, again it's below, that's why it's -4. And here again at quarter one, seasonal variation, we are below the trend line. So what is the average? Let's have a look. We're going to add up our three seasonal variations. We have -42, add, -44, add, -40. Making sure we're keeping in those negatives. Dividing through by 3 to find the average, -126 divided by 3 gives us -42. It's really important, you must keep the negatives here. Here we have hundreds on the line there, or indeed you can write it out as here, 4200. So 4,200, negative, really important. Okay, we're then asked, using our answer to the part below and our trend line, find an estimate for the number of people going to the cinema in quarter one of year 4. So let's take a look at our trend line on the previous page. We're going to extend our line here. Our trend line is not long enough. It does not go to year 4, quarter 1. We can extend it here. So extending our line along, we can see here that at quarter 1 in year 4, we're looking at approximately 100. Okay, so here we have the trend line value. So this is what's predicted. Now we have our average seasonal variation. So we will subtract our average seasonal variation, which we've calculated from the previous part, and we will have 5,800. Now again, the mark scheme allows for any answer between 6,000 and 8,500. It will depend here on how you have drawn exactly your trend line. Question number 5. The table gives information about the number of sparrows using a bird feeder in each quarter of 2006 and 2007. The first 4-point moving averages for these data are as follows here. We're asked to work out the last 4-point moving average. So we're going to add up these 4 values and divide by 4. 539.9. We're then asked to describe what the table shows and what the moving averages show about the number of sparrows using the bird feeder over this 2-year period. Now there's 2 marks available for this. So our first mark is from saying that the trend is decreasing. We can see here from the moving averages, the numbers decreasing. So the trend is decreasing. Now there's 2 marks here, so we need to mention something about the seasonal variation. If we have a look here, we can see that in quarter 2 of both years, the most number of sparrows. We can see in quarter 4, the least number of sparrows. So not only is the trend decreasing, the quarters show a seasonal variation. Question number 6. The table shows the information, shows the number of houses sold by Houses Direct in successive 4-month periods in the years 2001 to 2003. We're asked to complete the table. We can see here that we're doing 3-point moving averages. Our first moving average is by adding up 9, 26 and 19 and dividing by 3 to get 18. So you need to now complete the remaining moving averages. So our next one for this value here is going to come from 12, 32 and 22. So 12 plus 32 plus 22 divide by 3 will give us our moving average of 22. Our second one, 32 plus 22 plus 15 divide by 3, moving average 23. This now continues. There's 2 more moving averages to calculate. And lastly here, 26. We're then asked to plot these moving averages on the graph below. Okay, so we need to make sure this is in the middle. We're looking at 3-point moving averages from 1 to 3, so the middle is going to be on the 2 here. So this is where we're going to start here, up to 18. So just here. Our next one will be from here, the middle being 3. So we can see here that we're going to go along 1 quarter at a time. 3 and 19, just there. 1 and 21. 2 and 22. 3 and 23. 1 there. 1 and 25. And 2 and 26. Excellent. So we're then asked that told that there was an increase in the number of houses sold in some areas of England in these years. And it was claimed that Houses Direct is one of these areas. Write down one reason why this claim might be true. So, is housing direct in this area of houses increasing? Now we can see here from our trend line, if we draw in our trend line, we can see that house numbers are increasing. The line is going up. So actually, one reason why this could be true is that there is an upward trend. Therefore, Houses Direct may well be in one of these areas of England where the number of houses sold were increasing. However, there are other reasons why the number of houses at Houses Direct may have been increasing, and therefore the claim would be false. So there are many reasons as to why the number of houses would increase. Maybe there's a new manager who has a new strategy and has increased the number of sales. Maybe they've spent more money on publicity. Any other factor that might actually increase the sales rather than Houses Direct having to be in one of these areas where the houses numbers have increased. Question number 7. A gift shop sells wrapping paper. The table gives information about the sales of wrapping paper in pounds for successive 4-month periods from the start of 2002 to the end of 2004. We're asked to complete the table to show the other 3-point moving averages. We can see here that our next one will come from taking these 3 values, adding up, dividing by 3. Following the pattern and showing your working out as has been done before, our first moving average is equal to 30. Then moving down, 36 plus 29 plus 31. Divide by 3 is equal to 32. Lastly, 29 plus 31 plus 42 all added up and divided by 3 will give us our moving average of 34. Now, plotting these onto the time series graph, we need to make sure that we are choosing the middle. So here, our 3-point moving average is based on the 3 periods. The middle period is 2, so our first value will be plotted at 2 and 25. We have 20, 2, 3, 4, 5. So we will have our point here. Then we'll be plotting 3 and 27. 1 and 28. 2 and 29. 3 and 30. 1 and 32. 2 and 34. Once you have drawn your 3-point moving averages, you can then draw in a trend line which will make it easier to identify the trend. So again, a trend line is a line of best fit through our moving averages and approximately there. We're asked, what do the moving averages show about the trend of sales in wrapping paper? We can see that the sales are increasing because the trend line is increasing. We're then told that the time series graph shows that there are seasonal variations in the sales of wrapping paper. Asked to identify which period and a reason for this. In which period are there more sales than the general trend? We are looking here now at the points here that are higher than the trend line, the general trend. And this here is in period 3. Looking at our table here, period 3 corresponds with September to December. In every year, obviously, it is the same. So when asked to identify the period, we can state period 3, or we can put down that it's the September to December months, which might help you when you're thinking about a reason for this. Why is the shop having increased sales of wrapping paper during the months of September to December? Well, as you all know, at the end of December, we have Christmas where lots and lots of people are buying wrapping paper. So Christmas wrapping paper may well be the reason for the increased number of sales at this particular shop during the period September to December. Question number 8. The table gives information about the number of cars made in the UK for each 4-month period from 2003 to 2005 to the nearest 10,000. Here we have 3-point moving averages that have been calculated. First off, you're asked to complete the remaining 2 moving averages. For our last value here, we're going to add these up and divide by 3, which gives us a moving average of 53. The penultimate, the moving average here, is where we add up these 3 values. Divide by 3, our moving average is 54. We're then asked to plot these moving averages on the time series graph. So looking here, we're plotting. We can see here that our midpoint for our first moving average is here against 2. So we're plotting 2 and 55.3. So we're going here to 2, all the way up to 55.3. So that will be 1.5 squares, making sure we're reading the scale properly. Then for 3, we're going across to 55.7. So 55.2, 0.4, 0.6, halfway there for 7. Then to 1 for 55.3. So back down here where our previous one was. 2, 55. 3 down, 54.7. That's 55 down there. then across 1 to 54, and here for 2 to 53. Once you've drawn these, we're then asked, what do the moving averages show about the trend in the number of cars made in the UK from 2004 to 2005? What's happening? These points are going downhill. We have a decreasing trend. That's for part B of the question. We're then told that the time series graph shows there are seasonal variations in the number of cars made. Write down the period where there are fewer cars made than the general trend. So looking here at our numbers, we're looking for where the fewer cars are made. So for each year, we have this part. 53 is the lowest. Here, 52 is the lowest, 58 is higher, 53 is higher. 55 is higher. And here, 50. So we can see here that the period from May to August is where the fewer cars are being made. We're then asked to suggest a reason why. So anything that's a sensible reason. During this time from May to August, it's during the holidays. So maybe people are on holiday and not building cars during this period. Maybe people are not buying cars, therefore less cars are made. Maybe it's where the new license plates and people are waiting for the new license plates or when the new models come out. Any sensible reason that would suggest that not many cars are being bought during this period. We've now come to the end of session 7. Please revise the list of subtopics shown here on the screen and replay the video for any sections that you would like to study again.